Okay, today we're going to be going over the gradient vector. So the gradient vector is the vector that tells us where the rate of fastest increase is. So if we had a 3D graph here, and we had a function that went something like this, our gradient vector is going to tell us that this would be our fastest increase. It is like a compass that points us in the direction where the function's value increases the most rapidly. What the gradient vector is and how to calculate it is it's going to be the upside down triangle of your function of, for here we'll do x and y, and this is just going to be equal the partial of f with respect to x and the partial of f with respect to y. So for example, if we had a function, so if we have our x of f and y is equal to x squared plus y squared, then our gradient of f of xy would be equal to the partial of f with respect to x and the partial of f with respect to y, which is going to be equal to 2x and 2y. And that's what our gradient vector will be. So here we have question 10, so our first step is finding the gradient of f. And our f is equal to x squared ln y. So our gradient of f here will be equal to 2x ln y and x squared over y, because we just did the partial with respect to x, and then here we did the partial with respect to y. Since the derivative of ln of y, it goes to 1 over y. So that is part A done. Now part B, it wants us to evaluate the gradient at point P, where our point is going to be 3 and 1. So all we have to do is put our point into our gradient. So this becomes 2 multiplied by 3 ln of 1 and 3 squared over 1. So since ln of 1 is equal to 0, this becomes 0, and 9 over 1 is just 9. And now for part C, it says find the rate of change of f at P in the direction of u, with our vector u being negative 5 over 13 I plus 12 over 13 j. So here what we want to do is we want to take our answer from part B, so our 0 and 9, and to find our d of u of f of x and y is going to be equal to the partial of x of f and y multiplied by a, which is going to be the first term in the u, or whatever has the I, and then it's going to be plus f of y of x and y, the partial of y of x and y multiplied by b, which is our second term. So here we get 0 multiplied by negative 5 over 13, which just becomes 0, plus 12 over 13 multiplied by 9, which will give you your final answer of 108 over 13. Here we have question 8. So we need to find the gradient of f. For part B, we need to evaluate the gradient at point P, and then C, we need to find the rate of change of f at P in the direction of u. So the first thing we need to do is find the gradient of f with our f of xy equaling to x squared e to the y. So our gradient of f of xy is going to be equal to the partial of x, which is going to be 2x e to the y, and then our partial of y, which is x squared e to the y. And then you're done. So for part B, we need to find the gradient at point P, where our P is equal to 3 and 0. So all we need to do now is put our point into our gradient function. So our gradient of f, but instead of xy, is going to be 3 and 0, which is going to be equal to 2 multiplied by 3 multiplied by e to the 0, and 3 squared multiplied by e to the 0, which is just going to get you 6 and 9, since e to the 0 is 1. And then finally for part C, to find the rate of change of f at P in the direction of u, what we need to do is use the formula where we have the direction of u, and then f of xy is equal to the partial of x of x and y multiplied by a plus the partial of y of x and y multiplied by b. So for our part C, we have a u as equal to 3 over 5i and negative 4 over 5j. So what our a and b mean in this question is whatever term is with an I is going to be our a value, and whatever term is our j is going to be our b value. And then if we had a k value, it would be our c. So if we were to change this formula to x, y, and z, this will just have to add f of z of x, y, z multiplied by c. But since ours is in just 2-dimension, we'll keep it as that. So now this just becomes our value of f at our partial of f, our partial of x of f and y, but since it has to be at point P, that means it's going to be our value of 6. So it's going to be 6 multiplied by 3/5 plus our partial of y, which is our 9, multiplied by negative 4 over 5, because that's our b, which will give us our final answer of 18 over 5 minus 36 over 5, or negative 3.6.